was a program manager leading a cross-functional program within a national retail replenishment network with 12 distribution sites. I was asked to reduce weekend backlog at my site by 10%, but analysis showed every site recreated the same manual priority list each morning. I saw an opportunity to replace a local productivity fix with a network-wide method for prioritizing store-critical inventory. I could optimize my own roster, share a spreadsheet template, or prove a common prioritization mechanism and seek network sponsorship. I compared backlog age, store stockouts, and processing sequence across 3 sites. Fewer than 7% of units drove 54% of predicted stockout exposure, yet they were not consistently prioritized. I built a simple risk score from stock cover, sales rate, and delivery lead time, piloted a priority lane locally, and invited 2 other sites to challenge thresholds before scaling. Planning worried local managers would lose flexibility. I kept an override with a recorded reason and published false positive and missed priority rates weekly. The first model over-prioritized seasonal lines. I added a promotion flag and capped any one category at 30% of lane capacity before the multi-site trial. Before closing the action, I sampled performance across different shifts and demand conditions, so the result did not depend on one unusually experienced team or a quiet operating window. I translated the outcome into a simple frontline mechanism with a named owner, an escalation threshold, and a weekly measure, which made the change repeatable after I stepped away. I also documented the operating assumptions, named the owner for each follow-up action, and set a clear review date so that temporary controls could not quietly become permanent. I wrote the decision, assumptions, owners, and stop conditions on a 1-page control plan so the next shift could challenge the logic rather than rely on verbal context. I used both a leading indicator and a customer outcome measure that prevented a short-term productivity improvement from hiding quality, safety, or backlog age. During implementation, I stayed at the operating point for the first cycle, asked frontline employees what the mechanism missed, and changed only one variable at a time. I assigned named owners for each checkpoint and made escalation thresholds visible in the shift huddle, which reduced ambiguity when I was not physically present. After stabilization, I compared the result with the original baseline, checked for cost or defect displacement, and documented the mechanism for the other shifts. Before committing, I asked a supervisor who disagreed with me to identify the weakest assumption, then converted that concern into a measurable checkpoint rather than relying on consensus. I separated mandatory controls from preferences, which let the team move quickly without weakening the safety, quality, or customer promise that the operation existed to protect. For each alternative, I estimated the likely customer impact, labor requirement, operational reversibility, and worst credible failure, and I explained why my chosen path offered the best balance. I briefed affected teams before launch, checked understanding through questions rather than attendance, and made the escalation route clear to people working outside my shift. I also protected normal operations by defining which work would pause, which work would continue, and who could authorize expansion beyond the initial controlled scope. At every review point, I compared actual performance with the assumption that justified the decision. When they diverged, I changed the plan rather than defending the original recommendation. I made the cost of the choice visible as well as the benefit, because hiding overtime, rework, or displaced backlog would have made the result look stronger but less useful. Once the immediate issue was resolved, I held a short review with frontline representatives and partner teams, captured what failed in the original mechanism, and assigned permanent actions. My site's weekend backlog fell 23%, the 3-site trial reduced stockout exposure 18%, and the network adopted the score at all 12 sites. Annual lost sales avoidance was estimated at £3.4 million. Thinking big means recognizing a repeated mechanism behind a local problem, proving it at manageable scale, and designing flexibility and measurement into adoption.